Sedimentary rocks formation. Sedimentary rocks are formed through the gradual accumulation and consolidation of sedimentary materials over millions of years. This process involves several distinct stages, including weathering, erosion, transportation, deposition, compaction, and cementation. Weathering is the initial step in sedimentary rock formation, wherein various physical, chemical, and biological processes break down pre-existing rocks into smaller fragments or particles. Physical weathering includes processes like freeze-thaw cycles, abrasion, and exfoliation, while chemical weathering involves reactions such as hydrolysis, oxidation, and dissolution. Biological weathering occurs through the actions of organisms like plants, fungi, and burrowing animals. Once weathered, the fragmented rock material is transported by agents such as wind, water, ice, or gravity. Rivers, streams, glaciers, and ocean currents play crucial roles in transporting sediment from its source areas to deposition sites. During transportation, the sediments are sorted based on size, shape, and density, with finer particles often carried farther distances than coarser ones. Upon reaching a depositional environment, sediments settle out of the transporting medium and accumulate in layers. Common depositional environments include river deltas, lakes, floodplains, beaches, and ocean basins. The characteristics of the sediments deposited in these environments are influenced by factors such as the energy of the transporting medium, the availability of sediment, and the presence of organisms. As layers of sediment accumulate over time, the weight of the overlying material causes the lower layers to become compacted. Compaction reduces the pore spaces between sediment grains, resulting in the expulsion of air and water and the gradual compression of the sedimentary layers. Cementation is the final stage in sedimentary rock formation, where minerals precipitate from pore fluids and bind the sediment grains together. Common cementing minerals include calcite, quartz, and iron oxides, which are often derived from dissolved ions in groundwater. Cementation effectively transforms loose sediment into solid rock, forming cohesive sedimentary layers. The resulting sedimentary rocks exhibit a variety of textures, structures, and compositions depending on the specific conditions of their formation. Examples of sedimentary rocks include sandstone, shale, limestone, and conglomerate, each with distinct characteristics reflecting their depositional history and the properties of the original sediment. Overall, the formation of sedimentary rocks is a complex and dynamic process that reflects the interactions between geological, chemical, physical, and biological processes over vast spans of time. By studying sedimentary rocks, geologists can unravel Earth's history and gain insights into past environments, climates, and life forms. Sedimentary rocks formation process. The formation of sedimentary rocks is a multifaceted process that involves a series of interconnected geological, chemical, physical, and biological mechanisms acting over immense spans of time. These rocks are vital records of Earth's history, preserving evidence of past environments, climates, and life forms. Understanding the formation process of sedimentary rocks offers insights into the dynamic nature of our planet's surface and the interactions between various Earth systems. Weathering. The process begins with the breakdown of pre-existing rocks into smaller fragments or particles through weathering. This can occur through physical, chemical, and biological processes. Physical weathering involves the mechanical breakdown of rocks into smaller pieces, often facilitated by factors such as temperature fluctuations, frost action, and abrasion from wind and water. Chemical weathering involves the alteration of rock minerals through chemical reactions, such as hydrolysis, oxidation, and dissolution. Biological weathering involves the actions of organisms, such as plant roots, burrowing animals, and microorganisms, which contribute to the disintegration of rocks. Erosion. Once weathered, the loosened particles are transported from their source areas to deposition sites by agents such as water, wind, ice, or gravity. Erosion processes, including fluvial erosion by rivers and streams, glacial erosion by moving ice masses, aeolian erosion by wind, and gravitational erosion through landslides and mass wasting, play significant roles in transporting sediment across the Earth's surface. The energy and velocity of the transporting medium determine the size, shape, and distance traveled by the sediment particles. Transportation: sediment particles are carried by the transporting medium, undergoing sorting based on size, density, and shape during transit. High-energy environments, such as fast-flowing rivers and turbulent ocean currents, are capable of transporting larger, coarser particles over long distances, while low-energy environments, such as stagnant ponds and lakes, tend to retain finer-grained sediments. Sediment transport occurs in various depositional settings, including river channels, deltas, beaches, floodplains, glacial moraines, and deep ocean basins. Deposition: as the energy of the transporting medium decreases, sediment particles settle out and accumulate in layers at deposition sites. Depositional environments vary widely and include terrestrial, coastal, and marine settings. Sedimentary deposits in these environments exhibit distinct characteristics influenced by factors such as water depth, sediment supply, topography, and climate. For example, coastal environments may feature sandy beaches, muddy estuaries, or rocky cliffs, each supporting unique sedimentary facies reflecting their depositional history. Diagenesis: over time, the accumulated sediments undergo compaction and lithification, transforming loose sediment into solid rock. Compaction occurs as the weight of overlying sediment layers compresses the underlying material, reducing pore spaces and increasing sediment density. Lithification involves the cementation of sediment grains by minerals precipitated from pore fluids, such as calcite, quartz, and iron oxides. This cementation process binds sediment grains together, forming cohesive sedimentary rock layers. Post-depositional processes: after lithification, sedimentary rocks may undergo additional geological processes, such as deformation, metamorphism, and weathering. Tectonic forces can fold, fault, or uplift sedimentary rock layers, altering their original orientations and structures. Metamorphism can transform sedimentary rocks into new rock types through changes in temperature, pressure, and chemical composition. Weathering continues to modify sedimentary rocks at the Earth's surface, breaking them down into smaller fragments and contributing to the formation of sedimentary soils and sediments. Throughout this complex sequence of processes, sedimentary rocks serve as archives of Earth's history, preserving valuable information about past environments, geological events, and biological evolution. By studying sedimentary rocks and their associated structures, textures, and compositions, geologists can reconstruct past landscapes, decipher ancient climates, and unravel the history of life on Earth. Sedimentary rocks formation examples. Sedimentary rocks are formed through a variety of processes in diverse environments, resulting in a wide range of rock types with unique characteristics. Here are some examples of sedimentary rocks formed in different depositional settings. Sandstone. Sandstone is a common sedimentary rock composed of sand-sized grains of mineral, rock, or organic material. It typically forms in environments such as beaches, river channels, and sand dunes, where abundant sand is deposited and compacted over time. Sandstone can exhibit various textures, including well-rounded grains in well-sorted beds, indicating long transportation distances in high-energy environments, or angular grains in poorly sorted beds, suggesting shorter transportation distances in low-energy environments. Examples of sandstone formations include the Navajo Sandstone in the southwestern United States and the Red Sandstone formations in the UK. Shale. Shale is a fine-grained sedimentary rock composed of clay minerals, silt-sized particles, and organic matter. It commonly forms in low-energy depositional environments such as lake bottoms, deep ocean basins, and floodplains, where fine-grained sediments settle and accumulate slowly over time. Shale often exhibits facility, meaning it can easily split into thin layers along bedding plains. Examples of shale formations include the Marcellus Shale in the Appalachian Basin of North America and the Kimmeridge Clay in the UK. Limestone. Limestone is a carbonate sedimentary rock primarily composed of calcium carbonate, calcite or aragonite, derived from the shells and skeletons of marine organisms such as coral, foraminifera, and mollusks. It forms in warm, shallow marine environments with abundant calcium carbonate precipitation, such as coral reefs, lagoons, and carbonate platforms. Limestone can vary in texture from fine-grained to coarse-grained and may contain fossils of marine organisms. Examples of limestone formations include the White Cliffs of Dover in the UK, the limestone pavements of the Boyne in Ireland, and the limestone karst landscapes of the Yucatan Peninsula in Mexico. Conglomerate. Conglomerate is a coarse-grained sedimentary rock composed of rounded gravel-sized clasts, greater than 2 mm, embedded in a matrix of finer-grained sediment, such as sand, silt, or clay. It typically forms in high-energy environments such as alluvial fans, braided rivers, and glacial moraines, where fast-flowing water transports and deposits coarse sediment. Conglomerate may exhibit a range of clast sizes and compositions, reflecting the geological history of the source area. Examples of conglomerate formations include the Boulder Conglomerate in Colorado, USA, and the glacial till deposits in Scandinavia. Coal. Coal is a combustible sedimentary rock formed from the accumulation and partial decomposition of plant debris in swampy environments over millions of years. It typically occurs in coal seams within sedimentary basins and is classified based on its carbon content and degree of coalification. Coal formation begins with the deposition of plant material in an anoxic environment, followed by burial, compaction, and heating, which drives off volatile components and concentrates carbon to form coal. Examples of coal deposits include the Appalachian Coal Basin in the eastern United States, the Ruhr Coal Basin in Germany, and the Bowen Basin in Australia. These examples illustrate the diverse range of sedimentary rocks formed through various depositional processes and environmental conditions. Each sedimentary rock type provides valuable insights into Earth's geological history and past environmental conditions.